Okay, so we're on phase 2, and phase 2 starts with what is a quadratic in form? Like, what does that even mean? And basically, you know how a standard quadratic is in the form ax squared plus bx plus c, where a, b, and c are numbers, and the squared term is your lead number, and then in the middle, the exponent value is really 1, and the 1 is half of 2. And that's what makes this quadratic. Well, a quadratic in form takes on these characteristics, but not as an x squared. So the first quadratic in form I want to show you is on page 134, and it's letter D. And it says f of x equals 4x to the fourth plus 12x squared plus 8. So we call this quadratic in form because it's a trinomial, which is 3 terms, and the middle term is exponent is half of the lead term's exponent. That's what makes this a quadratic in form. And we can treat this just like a quadratic, meaning that we're going to factor it the same way we would a quadratic. Now, what I see right off the bat is a GCF. And the first thing I want to do is take out that GCF. So I'm going to take out the 4, factor out that 4, and I'm going to end up with x to the fourth plus 3x squared plus 2. Now, isn't that funny how this looks so complicated, but if I gave you the quadratic with an x squared plus 3x plus 2, it would be super easy to factor. In fact, that's exactly how we're going to handle it. Except instead of putting x in x, we're going to have x squared and x squared. But our factors of 2 that add up to 3 are just 2 times 1. So there they are. Okay, so now that we have this isn't completely factored. Don't forget that you cannot break these down any further because they're adding. And if it was a subtraction, we would be able to factor this more because it's a perfect square. This one, even if it was a minus, you wouldn't be able to do it. So now that we're in this spot, what we're going to do is finish this up. We're going to set these equal to 0. I did this a little out of order, but I just got excited. I wanted to show you how this factored. So we're just going to find the x-intercepts first, then we'll talk about everything else. Remember, I can't factor that. So I have to isolate the x squared and then take the square root. And when I take the square root of this, it's a negative. So I'm going to end up with plus or minus I square root 2, because it's not a perfect square. When I subtract 1 on this side, I get x squared equals negative 1. And when I take the square root of both sides, I get x equals plus or minus the square root of negative 1. This definition is I. So what does that tell me? Well, here's 2 complex roots. 2 more complex roots. And what that means is you have no places where it crosses the x-axis. It does not cross the x-axis. That's what that means. So when you have all complex roots, it doesn't cross the x-axis. Well, how could that be? Well, let's go back to the beginning. Let's go back up here and start our process. The first thing I need to do is figure out what degree I'm in. Look at our highest exponent. It's a 4. That makes it a quartic. Is the a value positive or negative? Well, that's positive. So because it's a positive A value, our quartic has end behavior where it's going to point up at the start and at the finish. And it kind of resembles a little W or a warped W. So this is the kind of shape we're looking at. So we have a y-intercept. Remember, that's the next part we always do. And our y-intercept is always 0, comma, whatever the constant is, and our constant in this case is 8. The last thing we had to do is find our x-intercepts. This is where I got excited because I wanted to show you how it factored. Quadratic in form. This is how it factors. And look what it comes down to. So how can this look like a W, cross at 0, 8, but not cross the x-intercept or the x-axis at all? Well, that's easy. It floats. Here's the x-axis, here's the y-axis. Here's 0, 8. It's going to float. I have no idea where these are called relative maxes and mins are. I have no idea where these lumps go in the scheme of things. All I know is it's got to point up because of its end behavior. Resembles a W. It crosses the y-axis at 8, and it floats over the x-axis.